Hello, in our previous video of storage management, Satish explained to you about the layout of our existing hard disk on our existing server, and there we saw that there are two physical partitions, two primary partitions there. The first one was mounted on a directory called as boot, and the second one was actually not mounted. It was actually part of what we call as a logical volume manager concept. So we are going to talk about that LVM concept, and we saw that this second partition was a PV. PV stands for the physical volume. So let me kind of draw another diagram to explain that logical volume manager concept to you. So this is now one partition, and let us say this is now another partition. You can consider this as a partition, or you can consider this as a disk also. So because in all our discussions, partitions and disks, we are going to kind of use them interchangeably. So these are the two partitions or two disks, and when these two disks are initialized through a certain command, then what happens is we say that we have initialized that disk, and it becomes a PV, the physical volume. So now after initializing, the PV physical volume is created, that created over here. Now these two physical volumes, let us say the size of the first physical volume is 10 gigabyte, the size of the second physical volume is let us say a 20 gigabyte, and so combined size is 30 gigabyte. What people do after that, the system administrators do after that, combined both of this, they will create what is called as a VG. So this green thing is a VG. VG stands for a volume group, VG, and all the PVs and VGs, they usually are given names. So we'll see what their names are. But what is created by combining two physical volumes is what is called as a VG, a volume group. And when you create a volume group, you decide that we are going to create what is called as the smallest chunk of the disk, and we're going to divide your entire volume group into that smallest chunk, and that smallest chunk is called as a PE, that stands for physical extents. Physical extent. Let me kind of explain this concept one more time. What we have created is a VG. The green thing is a VG, and within VG we have kind of created small sections of what we call as physical extent. So now in this case, let us say my first PV is of 10 gigabyte, the second PV is of 20 gigabytes, so combined VG volume group is of 30 gigabytes. Now when we are creating the volume group, we are going to say this 30 gigabytes is going to be divided into smaller chunks, into smaller units, and these units are physical extents, and you can say these smaller units are going to be of size maybe 4 megabytes. These are going to be smaller chunks. So if you just do the mathematical calculations, how many 4 megabyte smaller pieces, how many 4 megabytes physical extents can fit into 30 gigabytes of volume group, and that calculation is going to be a huge calculation which you can do on the side. But that is what a concept of a physical extent is. Physical extent is the PE, which is actually a smaller unit of division, the kind of smaller unit of division of the volume group. And this PE, physical extent, is going to help us to create the next level, the next step, which is called as a logical volume, which is the LV. So now from this PV, now I'm going to draw a separate diagram right next here. Now let me do this PV thing. So let us say my PV is like this. Now I'm not showing in this diagram, not PV, my VG is like this. I'm not showing the PVs in this diagram, but think that this VG is divided into smaller units of 4 megabytes each, and out of those 4 megabytes I'm going to carve a piece which is, let us say, this much of piece, and this much of piece is going to be, let us say, 100 physical extents, and 100 physical extents, each of them 4 megabytes, is going to be 400 megabytes. Then let us say I created one more of them and maybe this time it is little more, which is the 200 physical extents. 200 physical extents multiplied by 4 megabytes for each extent, that will make it 800 megabytes. So these are called as what we say LVs, the logical volumes LV. So this is the bigger LV, this is the smaller LV, all these are LVs. Now what is the greatest thing about all this physical volumes, combining them together in what is called as a volume group, and again carving those that volume group into the smaller extents called as PEs, and then creating LVs. All this kind of looks like a complicated way of doing this, but the greatest advantage of doing this is that when we create an LV, we are going to mount a directory on top of that. We are going to mount a directory on top of that, and let us say that directory is running out of disk space. We need to store more data there, so we can immediately come back to our concept of this PVs and LVs and VGs, and we can extend the LV very easily within that VG. So let us say this VG is not VG, my LV is kind of small, and now I have extended that by making an addition. So here now this after the addition, the LV became, let us say, double the size from 400 megabytes to 800 megabytes. So addition, the advantage of using the logical volume manager is that very easily you can extend or reduce the size of the logical volumes, and thereby extending or reducing the size of the directories in which we store the data. So that is the biggest advantage. So in our next video, we are going to see how to find out the informations about the PVs, the physical volumes, how to find out the information about VG, and how to find out information about LVs. So all this is the concept of what is called as a logical volume manager. So let us jump into the actual commands which will give us this information, and also we will see how to create the PVs, the VGs, the LVs, and all that stuff. So there are commands to display the information, there are commands to create these PVs and LVs and VGs, and there are also commands to manipulate them, that means to increase the sizes and decrease the sizes. So these are set of commands that we are going to look into, and that is what we will see in our next section.